At the edge of infinity, how big is the universe really? The Milky Way galaxy is absolutely massive, spanning over 100,000 light-years across. To put that into perspective, traveling at the speed of light, it would take you a literal 100 millennia just to cross from one edge to the other. But brace yourselves, you could fit 10 million Milky Ways inside the known universe. So, when we really think about it, the word big sounds almost ridiculous, completely losing its meaning next to the scales of the cosmos. On top of that, far from standing still or resting in a quiet cosmic slumber, this magnificent structure expands exponentially every single second. In fact, cosmologists have calculated that in about 1 billion years, space-time itself will stretch so much that the universe will be roughly 10% larger than it is right now. So what exactly are we sitting in? Is it genuinely possible to map out this colossal, ever-growing abyss? Or are we forever doomed to stare into a darkness we can never truly comprehend? Let's start with what we can actually see, because our reality is bound by strict physics. Light has a cosmic speed limit, traveling at about 300,000 kilometers per second through the vacuum of space. Because the universe has a finite age of nearly 13.8 billion years, light from the most incredibly distant regions simply hasn't had enough time to make the journey to our telescopes yet. That's why we can't see everything all at once. We are effectively trapped inside a bubble where light has managed to reach Earth. We call this boundary the observable universe. And even in this limited cosmic bubble, we estimate there are about 170 billion to potentially 2 trillion galaxies, each containing hundreds of billions of stars, planetary systems, and cosmic wonders. 170 billion. It is a number so vast it defies human imagination. To make sense of this absolute madness and bring order to the chaos, scientists set out to create a meticulous, unparalleled 3D map of the universe with the Sloan Digital Sky Survey project. This wasn't just about taking pretty pictures. They utilized specialized, custom-drilled metal plates fitted directly to a massive telescope to isolate individual galactic targets. By doing this, they could use a brilliant cosmic yardstick to measure the precise distance of these far-off galaxies from Earth, a phenomenon known as redshift. As galaxies move away from us through stretching space, the light waves they emit get stretched out too, shifting into longer, redder wavelengths. You know those breathtaking, hyper-realistic space scenes in the openings of major sci-fi movies like Interstellar or Star Wars. Thanks to this incredible mapping technique, those scenes stopped being wild science fiction and became reality itself, revealing a vast, interconnected cosmic web where entire galaxies form intricate, glowing filaments suspended in nothingness. But while building this monumental, awe-inspiring map, astronomers stumbled upon something incredibly strange, something that shattered their understanding of physics. The universe is held together by gravity, the invisible, heavy glue of the cosmos. However, when you mathematically add up all the visible galaxies, gas clouds, interstellar dust, and stars in the universe, the resulting gravity wasn't nearly enough to hold this massive structure together. By all accounts of standard physics, these spinning galaxies should have flown apart, tearing themselves to pieces. A massive, unimaginable chunk of matter was practically missing from the equations. That's when scientists realized there's a mysterious, ghost-like force out there that we cannot directly see. Yet it completely dominates how galaxies spin and interact: dark matter. We can't see it in a lab, it doesn't emit heat, and it completely ignores light, but we know it's there, just like we know the wind is there because we see the trees sway and dance. The amount of dark matter in the universe is astonishingly 6 times greater than all the ordinary stars and dust clouds combined. The story twists even deeper, because the universe isn't just getting heavier with invisible ghosts. Even as we sit here right now watching this video, everything is running away from us without looking back. For a very long time, scientists confidently thought that the collective gravity of the universe would eventually slow this expansion down, maybe even causing the cosmos to collapse back in on itself. But they were dead wrong. This cosmic escape is actually speeding up every single second. Professor Saul Perlmutter and his elite team proved this terrifying, accelerated expansion by studying distant exploding stars called Type 1a supernovas, ultimately bagging the Nobel Prize in 2011 for their mind-shattering discovery. But who or what is pushing these colossal galaxies from behind? We honestly don't know, but we gave this mysterious, anti-gravitational pushing force a name: dark energy. About 68% of the entire universe is made of this strange energy. And here is the absolute craziest part. As the universe grows and expands, this energy doesn't dilute, fade, or get weaker. When the universe doubles in size, dark energy doubles too, maintaining a constant density and driving the cosmos apart faster and faster into an icy, dark future. So, how on earth do you measure this massive, cosmic beast that keeps inflating at an alarming rate and is packed to the brim with invisible matter? Cosmologists pulled off a mind-boggling genius experiment by measuring the tiny, ancient temperature fluctuations in the oldest light in existence, the cosmic microwave background, the fading echo of the Big Bang itself. By analyzing these ancient, primordial patterns, they drew a giant, cosmic triangle across the depths of space-time. If the universe were curved like a ball or a sphere, the interior angles of this triangle would add up to more than 180 degrees. But do you know what the definitive result was? Exactly 180 degrees. In other words, space is flat. We aren't talking about a flat, two-dimensional sheet of paper here. We are talking about the pristine geometry of space-time. In a flat universe, parallel beams of light travel straight ahead forever without ever bending, intersecting, or looping. If the universe weren't flat, and you stared out into the dark with a powerful enough telescope for a long enough time, the light would curve around the geometry of space, and you'd eventually find yourself staring right at the back of your own head. This cosmic flatness shows us just one mind-bending, absolute truth. We are likely living in a bottomless, infinite ocean that stretches out with endless galaxies in every single direction. Up, down, left, right, and it just keeps expanding forever into the unknown. Absolutely mind-blowing, isn't it?